In this session, we are going to delve into 4 key link aggregation methods that are integral when working with data collections: Max, MaxBy, Min, and MinBy. For illustrative purposes, let's consider a data table that lists products, each with a price column. Using Max, we can quickly determine the highest price in the table, and with Min, we find the lowest. The result will be a decimal or integer, depending on the data type of the price column. But what if we want more context? What if we want to identify not just the price, but also the product that carries that price tag? That's where MaxBy and MinBy come into play. MaxBy will give us the entire row with the highest price, and MinBy will return the row with the lowest price. It's important to note that while we are using a data table as an example here, the 4 methods are not limited to just data tables. They can be applied to any enumerable collection, such as arrays, lists, or any other data structure that implements 𝗖𝗵𝗽𝗁. Both Max and Min come with a variety of overloads, 23 to be exact, that can handle different types of data, from numeric to alphanumeric. These overloads can be grouped into 3 categories. A simple call that directly retrieves the maximum or minimum value from a column. An overload that accepts a selector function, allowing for more complex queries on the data. An overload with a comparer, for times when you need to define specific comparison rules. The result of Max and Min methods is a value of the same data type what we have inside the collection. For example, if the collection is an array of integers, the result will be an integer; if it's a list of strings, the result will be of type string, and so on. The beauty of MaxBy and MinBy is in their ability to provide full details of the data row corresponding to the max or min value, based on a specific property like price. This is especially powerful when you are dealing with data tables, where each row contains multiple columns of related information. MaxBy and MinBy each offer 2 overloads to accommodate this functionality. The basic form takes a selector function and returns the object with the maximum or minimum property value. The second form allows for a custom comparison through an additional 𝗖𝗵𝗽𝗁 argument, providing even greater control over the comparison process. We will explore these methods, their overloads, and demonstrate their use with data table examples, showing you how to effectively query and analyze your data. Let's start with a simple example involving an array of integers. To find the maximum value, we use this query. Since our array consists of integers, the result will be an integer as well. Similarly, to find the minimum value, we use a corresponding query, which also returns an integer. This demonstrates the first overload of the Max and Min methods. Now, let's move on to a list of strings. Suppose we want to find the length of the longest and the shortest words in this list. For this, we will use the second overload of both Max and Min methods, which involves a lambda expression as a selector. This expression defines our criteria. In this case, we are interested in the length of the words, so we use the length property. The Max method will return the length of the longest word, while Min will return the length of the shortest word. So, the expression is used to define the criteria. In another scenario, let's consider a list of strings where some words are repeated in different cases, upper and lower. Using the first overload, the Max method will return the word Sarah in uppercase, as it's considered greater in alphabetical order, and Min will return the word Alex in lowercase. To handle this case insensitively, we use the third overload, which includes a string comparer to ignore case. The results will differ now. For similar words, the first encountered instance is considered. For example, Sarah in lowercase appears first among the various Sarah entries, so it will be the result for the Max method. Similarly, Alex with an uppercase A, being the first of its kind, will be returned by the Min method. Since our list contains strings, the result of these queries will also be of type string. And that's how you use all the overloads of the Max and Min methods effectively. Let's now delve into an example using a data table. Consider we have a table with a price column. Our goal is to find both the maximum and minimum prices in this column. Here's how we can achieve this. First, let's look at the queries for Max and Min. It's important to note that we must use the second overload of these methods, because we need to specify from which column we want to extract the maximum and minimum values. This requires a selector function, as simply calling Max or Min without any parameters won't suffice for a data table. In our queries, we define the content of the price column as a decimal type. While I have chosen to use decimal, you could opt for other types like double or integer. However, it's crucial to specify a type. If the column's type is not inherently decimal, you can convert its content using this conversion function. This conversion is essential, and you need to ensure that the column's contents can indeed be converted to a decimal to avoid exceptions. With these queries, the result we get is a single value of type decimal. But what if we want the entire row where the price is the highest or lowest? This is where MaxBy and MinBy come into play. Using MaxBy and MinBy with the same selector expressions gives us more than just a value. They return the complete row where the price is the maximum or minimum. As a result, the type of the output from MaxBy and MinBy is data row, not decimal. By using these methods, we are able to not only find the highest and lowest prices, but also retrieve all the details of the products associated with these prices. Let's now explore another example, this time using an XML file that contains the same product data as our previous data table example. We will utilize the four methods to find the maximum and minimum values. First, we need to parse the XML data into an XDocument object. This allows us to use LINQ to XML for querying the data. Starting with max and min, these queries will return a single value, specifically the maximum and minimum prices from our product data. The result type here is a decimal, representing just the price value. Now, let's shift our focus to MaxBy and MinBy. Unlike max and min, these methods don't just return the maximum or minimum value. They return the entire XML element corresponding to the product with the highest or lowest price. Therefore, the result type for these queries is XElement. This is similar to what we observed in the data table example, where the entire row was returned, not just the value. When we apply MaxBy and MinBy to a dictionary, the results are slightly different due to the structure of a dictionary. If we take a dictionary of string integer as an example, using MaxBy or MinBy will not give us a single integer or string. Instead, they return a key value pair of type string and integer. A key value pair is a structure that holds two values, a key and a value. In the context of our dictionary example, the key would be of type string, and the value would be of type integer. So, when we query the dictionary for the maximum or minimum value, what we receive is the entire pair that contains the highest or lowest integer value, along with its corresponding string key. To summarize, when working with simple data types like arrays or lists, MaxBy and MinBy will return a single value, such as a number or string. But when we deal with complex types like data tables, XML elements, or dictionaries, these methods give us the whole object. For data tables, it's a data row, for XML it's an X element, and for dictionaries, it's a key value pair with both the key and value. The other two methods, max and min, return always a single value, no matter which data type is used. Understanding this behavior is crucial for writing effective LINQ queries that return exactly what you need, whether it's a single value or a more complex object. And that concludes our comprehensive overview of these four key aggregation methods in LINQ.